So what if I told you that there's a planet out there, right here in our own solar system, that's so huge it doesn't really orbit the sun? Kind of breaks the rules, right? Well, today that's where we're headed. We're diving into the giant, the ancient, the undisputed king of our solar system, Jupiter.
Some people have called it the unappointed star that protects our solar system. I mean, that's pretty poetic, right? It basically frames Jupiter as this cosmic bodyguard. But what really makes this giant so special? And why is it so important for us right here on Earth? Well, let's get into it.
All right, first things first, we got to talk about Jupiter's most obvious, most defining feature. It's just mind-boggling size. I mean, to say it's big is a massive understatement. It is, no question, the king of the solar system. Okay, so how big are we really talking here? Try to wrap your head around this. If you could somehow hollow out Jupiter, you could fit 1,321 Earths inside. 1,321. That's a number so huge, it's almost impossible to actually picture. And this comparison right here really drives it home. Look at that. Our entire planet, our home, is just under 13,000 kilometers across. Then you look at Jupiter, it's almost 143,000 kilometers. That's like lining up more than 11 Earths end to end. Just wow. Okay, now here's where it gets absolutely nuts. Jupiter is so heavy, so massive, that it doesn't technically orbit the sun. No, really. They both orbit a shared center of gravity, and that point is actually just outside the sun's surface. Think about that. It's like a cosmic dance where Jupiter is big enough to pull the sun itself off-center. That's the kind of power we're dealing with. So you gotta ask, how did it get so huge? Well, the secret is all about location, location, location. It was born beyond something called the snow line. This was basically an imaginary line in the early solar system, and past this line, it was cold enough for stuff like water to freeze solid. So the baby Jupiter didn't just have rock to build itself with. It had a massive buffet of ice and gas, allowing it to grow into the absolute behemoth it is today. All right, we've talked about its size. Now let's zoom in a bit and take a look at what you might call a surface on Jupiter, if it even has one. We're talking about a world of storms, a place that is violent, chaotic, and honestly, just breathtakingly beautiful. So Jupiter's atmosphere is this incredible canvas of swirling stripes, right? The lighter bands, those are called zones. That's where gas is rising up. And the darker ones, the belts, that's where gas is sinking. This up and down motion creates these jet streams with winds screaming at over 360 kilometers per hour. And those wild colors, they come from chemicals we call chromophores. We don't know exactly what they are, but they're painting the whole planet. Oh, and the lightning? Yeah, it's about 1,000 times stronger than any lightning strike here on Earth. Just imagine that. And of course, we can't talk about Jupiter's storms without mentioning the big one, the Great Red Spot. It's the planet's most famous feature. I mean, look at this timeline. We might have been observing this thing since the 1600s. It's a storm that's been raging for centuries. At its biggest, it could have swallowed 3 Earths whole. But here's the crazy part. It's shrinking. We can see it happening. And the big question is, why? That's one of the great mysteries planetary scientists are working on right now. So, what's going on underneath all those swirling, chaotic clouds? Well, that's where things get even crazier. It's a world of extreme, almost unimaginable physics. We can't just look inside, obviously, but thanks to incredible missions like NASA's Juno, we're starting to peel back the layers and get a peek into the giant's mysterious heart. So, let's take a dive, shall we? We start in that thick, gaseous atmosphere, mostly hydrogen and helium. But as you go deeper, the pressure just gets insane. It gets so intense that the gas stops being a gas. It becomes a supercritical fluid, this really weird state of matter that's kind of like a gas and kind of like a liquid at the same time. But the real showstopper, the truly wild part, is what comes next: liquid metallic hydrogen. Okay, metallic hydrogen. This stuff it's just mind-bending. It's a form of matter so extreme that we can't even really make it here on Earth. Not for more than a split second in a lab. You've got to imagine pressure millions of times stronger than what we feel. It squeezes hydrogen atoms so hard that their electrons just pop off and start flowing freely. So hydrogen, the lightest gas, starts behaving like a liquid metal. It's conducting electricity. This, right here, is the planet's engine room. And what does an engine like that do? Well, it produces something massive. That churning, swirling ocean of metallic hydrogen generates the most powerful magnetic field in the entire solar system. I mean, just look at this comparison. It's 14 times stronger than Earth's magnetic field. It creates this enormous magnetic shield around Jupiter that's just unimaginably vast. But Jupiter's influence doesn't stop at its cloud tops. That immense gravity, it's not just holding the planet itself together. It has captured and commands an entire kingdom of moons. It's basically a miniature solar system, all orbiting one giant king.
And how many moons are we talking about? Well, as of 2025, the official count is 97, a staggering 97 moons. And this isn't just a bunch of similar rocks. This family has everything from tiny little captured asteroids to full-blown worlds that are actually bigger than the planet Mercury.
The real celebrities of this system, though, are the four big ones, the Galilean moons, discovered by Galileo himself way back in 1610. You've got Io, the volcanic pizza moon, just covered in eruptions. And then there's Europa, the one everyone's excited about, with a huge saltwater ocean hiding under a shell of ice. You have Ganymede, which is the largest moon in our entire solar system. And finally, there's Callisto, the ancient, battered, cratered sibling. These aren't just moons. They're unique, complex worlds. So why are these moons so active? I mean, they should be frozen, dead rocks, right? The secret is something called tidal flexing. It's basically Jupiter playing gravitational tug-of-war with them. As they orbit, Jupiter's massive gravity constantly squeezes and stretches their insides. All that friction generates a ton of heat. That's what powers all of Io's volcanoes, and it's what keeps the water on Europa a liquid ocean, warm enough for, well, who knows what. Which brings up a pretty important question, right? How on earth do we know any of this stuff about a place that's hundreds of millions of kilometers away? Well, the answer is an amazing story of human curiosity and ingenuity. It spans centuries of just looking up at the sky and decades of sending our robotic explorers out into the void. It really all kicked off in 1610 with Galileo and his newfangled telescope. That's when we first saw the moons. Then you fast forward all the way to 1979, and the Voyager probes flew by and gave us those iconic, stunning first close-up pictures. A huge leap forward. In 1995, we finally put a spacecraft in orbit around Jupiter, the Galileo mission. And right now, since 2016, the Juno spacecraft has been flying these daring passes over the poles, completely rewriting our understanding of how this giant planet works. And you know, the funny thing is, the more we learn from missions like Juno, the more we realize just how much we don't know. Jupiter isn't just some big planet out there. It's like a time capsule, a leftover from the birth of our solar system. With its strange, fuzzy core and those incredible moons hiding entire oceans, the King of the Planets holds clues that could honestly change everything we think we know about how solar systems form, and maybe even about life itself. So yeah, the journey to understand Jupiter is far, far from over.